Welcome to Oxboon, the technology magazine.
Hello and welcome. Yes, those were the days when we had to walk around the house in the dark with candles like this. That was the flashlight of our ancestors, so to speak. This vessel was called a candelabra, from the Latin candela, the candle. And candela is also a unit that we still use today to describe how light is measured. A candela is the amount of light emitted by a standard household candle. And it is relatively clear and obvious that this light is emitted in all directions throughout the room or almost throughout the room. And the candela denotes the total amount of light per solid angle. However, this also means that if we use lenses to ensure that this light is focused in a certain direction, for example, then this light is concentrated in this one direction and appears brighter there, even though the candle itself does not emit any more energy. To illustrate this better, I'll leave out the old-fashioned flashlight here, because I've also brought a modern flashlight with me. I have installed it here at the top of this gooseneck. We can see that it emits considerably more than one candela, but this is an example setup. And if we look at this here to explain the unit, we would actually have to be exactly 1 meter away from the surface here, and we would have to illuminate an area of exactly 1 square meter. That would be about 1 meter 13 in diameter for a circle. For the example here, because we just want to explain it, it's all a bit small, but the principle remains the same. And this is where the next unit comes in, which we can use to describe the light. If we illuminate a square meter of surface from a distance of 1 meter with 1 candela, then we have 1 lux at every point on the surface. But to keep things simple, there is another unit, namely the lumen. And the lumen is independent of the area that is illuminated, but it is about the luminous flux, about the light that comes from the light source. And I can also show you that. I have a flashlight here that I can control. And if I hold this up to the camera, we can see that this is a luminous flux of 1 lumen. If I switch to the next level, then we have a luminous flux of 15 lumens. And we can already see the effects of the camera's optics. Of course, the camera is now down-regulating, but there are also effects from the large amount of light, from the bright light in the optics, which we can observe here. If I switch to the next level, then we have 65 lumens, and we can see that the effects are increasing. The camera is already completely overdriven. In the next step, there are now 200 lumens, and I can take the whole thing to the extreme. And then we have 1,000 lumens. So that's 1,000 lumens, and you can see that the background of the picture is barely recognizable. The camera is completely overdriven. But that was just a qualitative description. We also want to express exactly. We want to measure exactly how strong the light is, just as we measure voltages, just as we measure weights, just as we describe other units in our lives, in technology, and in science. We have to do the same with light, with units, with measuring devices. After all, it is quite clear that we need certain guidelines, certain definitions of how bright a workplace is, so that people do not become ill if it is too dark in the workplace or in schools, for example. We need a certain amount of light in exhibitions, in museums, so that the exhibits on display are shown to their best advantage. And I have brought along a silicon diode here, a photodiode, which in principle also functions as a light-emitting diode, so it can also light up, but it can also be operated in the opposite direction, namely that it converts the light it receives into a current, and we can in turn measure this current. And that's why I've brought a measuring device with me. And when we look at the display, we see a low voltage caused by the ambient light. If I try to hold the LED closed, we can see that the voltage drops to 0. And if I take my flashlight again and shine it directly on here, we see that we now suddenly have a voltage of about 2.2 volts. If I take the flashlight away, the voltage collapses again and the voltage is back here. This means that we are able to measure the light here numerically. And of course there are also measuring devices that are specialized for this, that can be calibrated and that we can take outside with us, anywhere in the area where we have to use it, and with which we can measure in a highly specialized way how bright it is there. I have brought you the PCE LMD10, a light meter that can measure from 0 to 400,000 lux, which is up to 400 kilolux. And the device is supplied with an external probe, which we can see here. And as we can see on the display, it is already in measuring mode, in the measuring screen. And when the probe is still, we can see the ambient brightness here. And if I cover the probe, then you can also see not only that the display has just decreased the value, no, now it has also changed the unit. It can also measure foot candles, which is common in the USA, but is also usually lux here, as you can see here in the display. And if I take my little flashlight and measure it, you can also see here that the value goes up. The device has various functions. For example, I can display minimum and maximum values. So if I cover the sensor again, for example, I can measure somewhere in a place that is difficult to access, and then query the device afterwards to see how bright it was in that place, as we can see here. There is a hold function for a current value. There is a peak function, so that the brightest value that was measured is displayed, and the device can store 32,000 measured values. However, it is also possible to carry out live measurements via USB and read out the data, including the stored data, and then process it on the computer. It has a built-in rechargeable battery that is charged via USB. This makes it possible to take it with us wherever we need it. This is the PCE LMD10. Here we see the PCE UV40A, a light meter that has the special feature that it can not only measure visual light from 0 to 10 kilolux, which is 10,000 lux, but is also able to measure UV light, up to 100 watts per square meter. And it comes with such an external probe that can be mounted on such a rod, so that you are able to go to less accessible corners and also measure where it is difficult to reach manually, or where it is difficult to read values. If we look at the device, we can see that there is hardly any UV light here in our studio. I can demonstrate the measurement in the UV range by using my flashlight, which emits a small amount of UV light. What we see here is 0.06 watts per square meter. In other words, the special thing about this device is that it can measure the visual range and the UV range simultaneously. We can take a closer look at the device. It can save measured values. We can do this via the menu. So we can see here that we have the option of calibrating the device. Or we can go to the memory and have the option of loading saved values from the memory or saving new values. And we also have other setup functions, for example, to set the display or to set the measuring ranges. All in all, as you can see when I pick it up here, it's a nice, small, sturdy device. We have a USB port at the bottom here. It has a built-in battery and can be charged via USB. And that means we can take it with us wherever we go. The PCE UV40A. I have brought you the PCE LMD200. This is a light meter that can measure illuminance levels of up to 500 kilolux, which is 500,000 lux. And you can see that it has a large, easy-to-read display. It has the option of stopping the current value, You can see a stop symbol at the front if you want to make a note of it. And we can go into the menu and see the options for calibration. We can see that we can save measured values and call them up again afterwards on a memory card that we can insert into the device. We have other options for calibration and measurements, as I just said, and settings such as display contrast. The device comes with an external measurement probe, which we can see here and which is connected to the device via this cable. And if I move the device slightly to the side, we can see that this rod, this extension rod, is also included in the scope of delivery, which we can extend 4 more times here. And we have the holder at the top here, into which I can insert and attach this probe so that I can also measure the amount of light in places that are difficult to access. There is also an extension for this device, namely a luminance attachment, the PCE LMD LMA1. And it has a 100mm lens with a measuring field angle of 1 degree. And so we are almost able to use it for targeting. With this device, it is possible to measure the amount of light at a very specific location. And I've deliberately put it on a tripod here because with this small aperture angle, it's very, very important to align it precisely to actually reach the desired location. If I turn the device around, we can see an opening at the back here. And the sensor, the light sensor that I've just shown here, if I unscrew the ring here, I can now screw it on here at the back. So I can measure objects at a distance in a very similar way to a lens that I screw onto an SLR camera, for example. And the PCE LMD 200 is therefore able to carry out measurements both close up and at a distance. Finally, let's take another look at all the devices. Firstly, the PCE LMD 10, a handy device with a nice, large, readable display that covers all light measurement applications well on the move. Next, we have the PCE UV40A, a device that has the special feature of being able to measure both visual light and UV light at the same time. And finally, the PCE LMD 200, which is also available in a kit with the PCE LMD LMA1, the luminance attachment, so that we can measure the brightness conditions not only at close range, but also at a distance. Have a bright day, and goodbye.
Discover and order the latest measuring and test equipment now on www.pce-instruments.com.